Hello everyone, my name is Abhishek and I am from University of South Florida, Electrical Engineering Department, and I'm presenting my capstone project with my teammates Kevin Echevarria. This is my project where I have made a GPS L1 to L5 dual band antenna. This is my fabricated piece of the GPS antenna. As you can see, this is the feed board of the antenna which feeds towards the stack patch antenna. When I flip this board, you will see the stack patch antenna, which we'll be doing in a few minutes. But first, let me explain you the active system. So this is the first feedboard of the antenna, and this is the second feedboard of the antenna, which is on the top layer of the antenna, of the whole circuit board. The material is Rogers 4350, which has a dielectric constant of 3.66. As you can see, these two feedboards will bring the signal towards the coupler, which is right here. As you can see, these are the soldered components and these are the non-soldered footprints. So the quadrature hybrid coupler gets both the signals and will phase shift the signals by 90 degrees and will combine the ports here. As you can see, this is the combined port. So from this port, the signal will travel to the diplexer, which will basically divide the signals in L1 band, which is 1176.42 MHz, and L5 band, which is 1575.46 MHz. These two signals will be amplified by the low noise amplifier, which you can see here and here. The company of the low noise amplifier we have used is Mini Circuits, which has a gain of around 34 decibels, which is pretty good. From the low noise amplifiers, as you can see around the low noise amplifiers, there are capacitive and inductive networks, which produce the biasing network of the whole amplifier. And as you can see here, I have left gaps, which is basically the bridge of the system. If I flip the network, you will see the bridges are connected here and here using a wire. These bridges provide upper layer DC connection for the biasing network. From the middle of the bridge, the RF signal is traveling towards the combiner, which is the same component as the duplexer, but here it acts as a combiner and combines the both L1 and L5 bands so that the whole signal is combined into a single band. And now this whole combined signal is produced to the output here, which is the output coax cable of the antenna, which is fed to the digital coding network. As you can see, there are coax cables everywhere to test the individual components. And as you can see here, which is the other layer of the antenna, which has the quadrature hybrid coupler in it. And if I flip the board, you can see this is the stack patch antenna. These are the two stack patch networks. As you can see, the thickness is almost 360 mils, and the thickness of the active network is around 20 mils and 30 mils respectively. And these are the bridge boards which I have used to pass the DC from above the RF so that the DC and RF won't get mixed. This is my stack patch antenna, and this is my active network of the antenna, which will make a good GPS receiver system for more accurate positioning systems. Thank you very much.